Hi everyone, welcome to the lecture series on applied mechanics. Here we will discuss on the unit friction in the specifically wedge problems. So what we see, for example, example of a wedge problem, a 2-degree wedges are used to push the block horizontally as shown figure. Here this is one wedge, this is second wedge, right? Both are at 6 degrees angle, are used to push the block C horizontally this direction. Calculate the minimum force required to push the block of weight 10 kilonewton. So this C block 10 kilonewton, it has to go right hand side. So what force minimum required from the top, so that this will go right hand side. The take coefficient of friction 0.25 at all contact surfaces. That means where are the contact surface? One is this C block with the ground, B block and C block here, and A block and B block this contact surface. There are 3 contact surfaces. In all 3 contact surfaces, the coefficient of friction is 0.25. So let us solve this problem. So now first thing is you have to see which block, the wedge block, which is the moving. So first of all I want to say that this is the contact surface 1 and 2 and 3 is my identification. You can give any direction you want, 1, 2, 3 also you can give. Here I am considering contact between A and B is 1, B and C is 2, and C and the ground is 3. Now the free body diagram of wedge I will take this because this is what I am pushing down. So motion of this block I know. Okay, that decides the friction direction. Okay, block B goes downward. So let us draw the free body diagram of block wedge. Okay, so I will draw the wedge here. This is a wedge, which is a wedge, I call it as B. Okay. Now try to understand the forces. This is very important part of this problem. You need to know how to draw the forces on the block, which is called free body diagram. Now the first force I see here is the contact between B and C, right? So the contact surface from the B block is vertical, so normal force is N2, right? Now since this block is moving downward, the friction is upward, which is F2. Okay. Now what else is there? I have a friction force between B and A block, right? So now look at here, this block contact surface is inclined, so normal force will be inclined, normal to the surface, means perpendicular to this inclination. That means if I look at here, it must have a 90 degrees angle here. So this must be 90 degrees. This surface and this normal, right? This is very important. Then since the block is going down, the friction force must be the upward. That is along the direction of the surface, upward. Next force, I know I can see here the P, right? So the P is downward, I will represent here the P. Now the angle which is mentioned here 6 degree, that means if I draw a vertical like this from this point, this angle is 6 degrees. Also meaning that at this block, if I draw a vertical there, this angle is 6 degrees. That's all. Now once I understand this free body diagram of the block, simply write the equilibrium equation, summation fx equal to 0, summation fy equal to 0, that's all. Assuming that all these forces like P, if I extend like this, N2 and N1, all the 3 meets at one point, right? That is the understanding here. So if I say extend this force, extend this force, extend this, all are meeting at one point. So they are concurrent forces. So I can use equilibrium only 2, summation fx, summation fy, no movement is there. Apart from this, I have 2 friction equation, right? That means the friction force F is equal to mu times N. N is normal at that point. At this point, N normal is N1. At this point, N is N2. The mu is the coefficient of friction as per the given data. Maybe 0.25 or 0.2 or 0.3 as per the requirement, as per the given data. Okay. Now I can use equilibrium equation. EE is equilibrium equation. Summation Fx. So try to understand. N2 is perfectly horizontal. I don't have to worry. F2 is perfectly vertical. Nothing to worry. P is perfectly vertical down. Nothing to worry. Only two forces are inclined, which is F1 and N1. So I need to know what is angle of these forces. This is very important, right? So now summation. So I need to know, if I try to draw a horizontal here, so this angle is my 6 degree. This is what I need to understand, right? So now summation Fx, that is N2 minus, right, minus N2, then N1 cos 6 degree positive, N1 cos 6 degree positive, and F, if I take this F along the surface, if you go towards angle becomes vertical, away from angle is horizontal, and if I go away from horizontal like this, arrow goes left hand side, that's why minus. So minus F1 sin 6 degrees. Simple. Now summation Fy, F2 is there, minus P is there, F1 cos will be upward vertical, that is positive, and N1 cos was horizontal, N1 sin will be vertical, and what, right? So N1 sin 6 degrees here, this force, N1 sin 6 is N1 sin 6, this force, one is horizontal, second is vertical, upward positive, F1 cos, it is vertical upward positive, and F2 vertical positive, minus P downward. So simply if I solve these two problems, so I can see the unknowns. F1 I can write in terms of N1, that is what your friction equations. What is that? F1 is 0.2 times N1, F2 is 0.25 times N2. So I can replace F1, F2, I will have N1, N2. So N1, N1, N2, N1, N1, N2, and P. P is also unknown. So I have a 3 unknowns and 2 equations. So I cannot solve, I should get a 1 more equation. So now I will go to next block, maybe block C. So I will go to block C. So the block C, so try to draw the block C, simply a rectangular box, right? Now what are the forces onto this block? So one is contact surface 3, right? And second is the weight of the block. The weight of the block is 10 kilonewton. It is exactly acting at the centroid. Fine. Next is a ground. On the ground, when I push this block downward, this C block goes horizontal right hand side. When blocks move horizontal, friction force is left hand side. So friction force left hand side. And normal to the surface of the ground is a normal force, which is N3. Next, contact surface. This surface also perfectly vertical. So I have simple normal forces horizontal N2. Of course, whatever we have here, simply same force but opposite direction. N2 left hand side, N2 here on this block right hand side. F2 vertical here, and here F2 downward. Vertical downward, a vertical upward. Right? Now I don't have any inclined forces, so nothing to worry. Summation Fx, summation Fy becomes easy. Summation Fx, all force x direction, N2, F3, right? N2, F3. Then summation Fy, N3, 10, and F2, N3, F2, 10, right? So here how many unknowns? N2 already introduced here, and N3, of course F3 there, that is here F3 is mu N3, mu is nothing but 0.25, So I can write this mu as 0.25 n3. So n3 is one unknown, right? That's all. So in the previous equation, n1, n2 and p, and here is another is n3. So total 4 unknowns. I have 4 equations, 1, 2 here and 1, 2 here. So total 4 equations, 4 unknowns. I can solve the problem. So 0.25 n3. Solving these 4 equations, 4 unknowns, that you should take care. So I can find the force P. I hope you understand. So let us go to the next. Another problem. A block weighing 5000 Newton, that means 5 kilonewton here, is to be raised, means I have to lift this by means of 12-degree wedge. So I have a 12-degree wedge. I have to lift it. Assume mu is 0.3 for all surface of contact. That means there is a one contact surface here, second contact surface here, and third contact surface here. So what is the horizontal force P? So how much of P I have to apply? That should be applied to raise to the block, this upward. So the weight of wedge block, the wedge block also having some weight. So very important, first is the contact surface, right? So I will take free body diagram of wedge first, because I know I am pushing, I know the direction of force, right? So contact surface 1 here, so 2 here, 3 here, right? So I will take a free body diagram of wedge here. So right, so what are the forces on the wedge? So one is a P, second is the weight of this block, third is the normal at 2 points. So force which I am applying, right? And at the ground I have a normal which is N1, and since the block is will have to move left hand side, friction force is right hand side, right? This is what important. Then contact between the block B and the wedge. So the normal force is perpendicular to the inclined surface, and it has got a weight of 150. So weight always acts as gravity, that is y direction. Then contact surface. So since block is moving left hand side, friction force right hand side, and normal will be not exactly y. Normal is normal to the surface. Now it said that wedge is 12 degrees. So 12 degrees to the horizontal. So this surface is 12 degrees to the horizontal. That means the normal force is having 12 degrees to the vertical of the surface. This is what we need to understand. Otherwise, we will not be able to solve the problem. So now these are all perfectly horizontal, vertical, horizontal here. Only these two forces, N2 and F2, are inclined. So I will take component of this. Very simple. F2 cos will be horizontal, F2 sin will be vertical, N2 cos will be vertical, N2 sin will be horizontal. That's all. So summation of x, right? So x, what is that? F1 horizontal, P is horizontal minus F2 cos will be horizontal, N2 sin, N2 cos will be vertical, N2 sin will be horizontal, right hand side positive. Similarly vertical, what are the vertical direction? N1 150, N2 cos 12 degrees, F2 sin 12 degrees, F2 sin 12 degrees, N2 cos 12 degrees, right? So then friction equation, that is F equal to 0.3 N, it is N1 here, and because same friction coefficient all contact surfaces, F2 here will be 0.3 times N2, right? Now let us go to the block which I have to lift it, which is try to draw the free body diagram of that block, right? So let us take the block which has to be lifted. This is the block. Then what are the forces at the contact surface? Before that, having the weight which is 5000 Newton, and between the wall and the block there is a normal force N3 and since the block has to move upward, friction force will be going downward, right? Friction force comes down, then the contacts, between the contact, whatever I have written, these same forces I can write down, but in a opposite direction, right? So N2 will be vertical and F2 will be the reverse direction, and the angle we have to mention this 12 degrees. So since other forces are perfectly vertical and horizontal, only these two forces are inclined. So since I mentioned angle of these forces with respect to horizontal or vertical, so easy to take the component, right? Suppose summation Fx equal to 0, equilibrium equation. What are x direction? N3 is there, and this F2 cos 12 and N2 sin 12, N2 sin 12, F2 cos 12. Of course, both are in the left hand side, so minus. Similarly, summation Fy, y direction, what are they? F3 is there, 5000 is there, and N2 cos 12, F2 sin 12, F2 sin 12, N2 cos 12, and F3 5000. And friction equation, which is F3 equal to 0.3 N3. Right? By solving these equations, I will be able to find out N1, N2, N3, and P, because 4 unknowns. N1, N2, N3, and P, 4 unknowns, 4 equations. So I will be able to solve them easily. So let us go to the next problem. Determine the force P required to start the movement of the wedge. Here this wedge, I have to push it, right? The wedge, this is a wedge, has to be pushed. The angle of friction for all surface of contact is 15 degrees. Now he has not given the coefficient of friction, but angle of friction. So tan, this phi will be the angle of the coefficient of friction. So all the data are given here, the weight of this given. Here now the weight of the wedge is not given. So I can neglect the weight of the wedge. So solution, where free body diagram of wedge first, because this decides me the friction direction. So the free body diagram, the contact surface as usual 1, 2, 3, right? So let us take the coefficient of friction you have to decide, which is tan 15 degrees, which is 0.24. This becomes my coefficient of friction. So now the wedge has the force P horizontal. Now on the ground there is normal force, and since the block moving left hand side, friction force is opposite direction F1. Then between the contact, the inclined surface normal to the inclination is N2. The block is moving left hand side, the friction force right hand side, F2 is the upward, okay, along the surface always. Now this block has 20 degrees, so if I draw a vertical, because I need to know the angle of each of the inclined force. This is not inclined, not a problem. This is not inclined, not a problem. Problem is with these two. So look at the F2, that means F2 basically is like this on the surface. This is F2. This anything okay. So now, so this F2 has angle of 20 degrees with the x-axis horizontally. So not a problem. But N2, I did not mention the angle. So if I draw the vertical line like this, so this is 20, that means this is also 20 degrees. So the N2 cos 20 will be vertical, N2 sin 20 will be horizontal, right? So now this is what? So I decided 20 degrees. So summation Fx, simple, horizontal direction, I have F1, I have minus P, I have F2 cos 20 and N2 sin 20. Similarly, Fy, y direction, N1 is there and N2 cos 20 is there, F2 sin 20, right? Then friction equation, because coefficient of friction 0.24, N1, F1 equal to 0.24, N1, F2 equal to 0.24, N2. So let us go to the second block, which is to be lifted up. By pushing this block goes upward. So what are the forces on the block? 20 kilonewton force is there downward, right? Then the contact surface at the wall having the N3 normal force, block is moving upward. The block is moving upward, friction has to be downward at this surface. Then the between contact, whatever I mentioned here, same thing but opposite direction. So N2 will be upward like this, friction force downward like this. Then already angles are already mentioned there 20 degrees. So all the forces are given angle. So easy to write down summation Fx equal to 0 and summation Fy equal to 0. Right? Then friction equation F3, 0.24, N3, solving these 4 equations, and we have 4 unknowns N1, N2, N3 and P, so I can solve the problems. Similarly, the next problem, here the coefficient of frictions 0.25, 0.3 and 0.25 are different. Between the surfaces, the coefficient of friction is different. So between at the floor it is 0.25, at the wall 0.3, and between the blocks 0.2. That means the roughnesses are different. So he is asking find the minimum value of force P to be applied so that this block B will move upward. It moves upward. Minimum force of horizontal P applied to the lower block that will hold the system in equilibrium. Okay? So same way, contact surface is here 1 and 2 and 3. Just to say that I can say N1, F1, N2, F2, N3, F3. That is the idea. Right? Now, so I take this wedge block, free body diagram, because the block A, what happens? So what happening here, try to understand that this block B, I have to hold on, right? Hold on the system. That means it is trying to fall down. When this is trying to fall down, is coming down, this block will try to move. So I have to hold, right? So this will try to slide left hand side. So block A try to move left hand side, that is left moving, right? So based on that I can get the friction direction. So try to draw the free body diagram of block A, has a weight of 4450 Newton. Then the friction force. So this block will try to move left hand side, right? 1 minute. So the way we have to understand this problem, that this block is trying to come down. Find the minimum value of the horizontal force applied to the lower block that will hold the system equilibrium. That means I need to hold on this block. That means I have to just apply, just maintain that. I don't have to push this, right? So it is going to fall down otherwise, right? That means it is coming down. So it is coming down, the block B is moving. The block B is moving down, that means block A moving left, right? Block A moving down. So that's very important, understand this statement here, otherwise all your friction direction changes. Hold the system equilibrium, that means I don't have to push the block up. Hold the system equilibrium means I have to stop this coming down. Coming down means this block will go left. So A block will go left. So friction direction is right. Friction direction is right. So now the angle, and then in the between the contact of this, the friction this right. So this friction also this along the surface, which is this direction. So normal to the surface is N2. So that angle of this is very important, very here. So look at here, this block is 60 degrees is given here, 60 degrees. That means if I draw a vertical drop here, this is 30, 60, 90, total 180. So if this is 30, so if I draw a vertical line, this N2 also 30. So because N2 is inclined, F2 inclined, so I need to give an angle of these forces with respect to either horizontal or vertical. So then I have a force P which is to be applied here. So all these forces simply summation Fx. So x direction P is there, x direction F1 is there, and component of this N2, x direction is sine 30 minus F2 is cos sine 30. So Fx is equal to P1 positive, F1 positive, F2 sine 30. I don't have to take this angle now because this F2 is acting like this. So like this, the F2 is on the surface like this F2. And angle with vertical is 30. So F2 cos will be horizontal, F2 cos will be vertical, F2 sin will be horizontal. Right? This is what important. Then summation Fy, right? Fy is N1 is there, minus 4450 is there, right? Then N2 cos 30 will be downward, right? Downward minus. Then F2 cos 30 downward, right? Similarly, friction equations, right? Mu times N1, mu times N2. So now once I understand block this, I can take this block, B block, which is verge of falling down. So block B moving downwards. So if you take a block, so now what? Along the surface, contact surface, and one weight is there, so weight is downward. Along the contact surface, since the block is moving down, friction force is moving up, and normal to surface N3 is there. So between the block, so whatever force I wrote here, same force I have to write but change the direction. So N2 perpendicular, F2 upward. Angles anyway already mentioned as there. Right? So again write down summation Fx, x direction force is N3 minus N3, right? So minus N3. Then what else? N2 cos 30, N2 cos 30. Then F3, right, understand. If F3, if I say take like this, is this is F2, with respect to x angle is there, right? So F2 cos 60, it will be the left hand side minus. Similarly Fy, y direction, F3 is there, right? F3 is there, 2225 downward is there. Then F2 sine 60 upward, N2 sine 30 upward positive, right? Then friction equation, which is F3 equal to 0.3 N3, F2 equal to 0.2 N2. Then solving these 4 equations, 4 unknowns, I will get a force P to hold the system in equilibrium. Hold the system. I am not interested to push the block B up. If I have to push the block up and I have to push the block A right hand side, then everything changes. Okay, please remember this important understanding. Okay, thank you.